Here are the notes for N4. This is page 12 in your Unit 10 packet. So here we are balancing more chemical reaction equations, but you can see some of them will look a little different here. So now we have parentheses on some of them, on some of the molecules. So this parenthesis here, this OH in parentheses is called a polyatomic ion. What this means is certain elements like to stick together and they form molecules that then attach to other atoms to form larger molecules. And when you see these parentheses, this subscript applies to both things. So this is kind of like, just for counting purposes, OH2 like this, just for counting purposes, works like this. But in reality, the actual structure of the molecule, OH has a specific structure and there's two of them stuck together. So like if I have Mg here, it's attached, it's bonded to an OH and a second OH, which is why we have to write it like this in parentheses instead of O2H2 like this. This kind of implies it's just one big molecule with two oxygens and two hydrogens, but it works like this, two separate ones that are, in this case, ionically bonded to magnesium. But for counting purposes, just basically distribute that subscript to both things or however many things are in the parentheses. So then we just treat this like we do with all of our other balancing problems. So if we look here, if we start counting on the left side first, magnesium, just one. Oxygen, it shows up in two spots, so there's one right here and one right here. Oops, two. And then hydrogen, two of them. So there we go. On the right side, magnesium, one, and then one oxygen and one hydrogen. But remember the subscript 2, and they're in parentheses, so it distributes and kind of works out like this, two oxygens and two hydrogens. So this one is already balanced. So we can just put ones in for everything. In the next example here, no parentheses or polyatomic ions or anything, so we can just do our normal process. And we start by counting. So on the left side, one of everything. And on the right side, zinc we have 3, phosphorus we have 2, aluminum we have 2, and sulfur we have 3. So now I'll just go element by element and try to balance them. So we'll start over here. I know I need 3 zincs. So that's balanced, but that also changes sulfur. So I'll go down and change sulfur. That's good, that's what I needed. And then next one, aluminum, I need 2 over here. So there we go, now that's balanced. It also changes phosphorus, 2. So now it's balanced. 3 of zinc and sulfur, 2 of aluminum and phosphorus on both sides. So I can just fill in ones. And there we go. Next one here gets a little trickier because here we have this polyatomic ion again. So we'll do this 2 ways. So start by counting 1 iron here, Fe, 1 silver, Ag, 1 nitrogen, and 3 oxygens. On the right side, it's a little more complicated. So 1 iron, nitrogen here, there's 2 of them because we distribute this subscript to everything in the parentheses. Oxygen, there's 2 times 3, 6. And then silver, just 1. So this kind of works like coefficients, but this subscript, when you see it after parentheses, it just applies to the things inside the parentheses. So like this 2 doesn't go over and apply to the Fe. So like, remember, a coefficient applies to everything that comes after it. Now these subscripts only apply to the things that are in parentheses, or if they're not in parentheses like this one, it just applies to the one directly before it. So that's why we have 2 nitrogens and 6 oxygens. 2 times 3 gets us 6 oxygens. All right, to balance, iron and silver are already balanced, so nitrogen is up next. I need 2 of them. So that changes a couple things here. It changes silver, now I have 2. And it changes oxygen, 2 times 3 gets me 6. So now oxygen works out, nitrogen works out, silver is unbalanced. So I need to do that one. And now this thing is balanced. So 1, 2, 1, 2. Alternatively, there's another way to balance when we see these polyatomic ions that makes things go a little bit faster. So this way will always work, but it takes a little longer to count these things individually. So let me clear this. And we'll do a slightly faster way to do this with the polyatomic ions. Instead of counting NO3 separately as a nitrogen and an oxygen, when we see these as polyatomic ions, so if you see something in parentheses and it shows up both sides, so it doesn't have parentheses over here, but see how we have NO3 and then we have NO3 over here, and no nitrogens or oxygens show up anywhere else, kind of a counting shortcut we can do is put the whole thing together like this. And then I'll count NO3 all together as one thing, because you can see it shows up on both sides as like NO3 as that combination. So then if I were to do this one, I have 1 iron on both sides, 1 silver on both sides to start, and then this is called nitrate. This nitrate here, I have 1 on the left side, NO3, and I have 2 on the right side. So then I know I just need 2 over here. Now I have 2 of these NO3 things like all together as a group, and that also changes silver. So then I need another one over there. So if that was a little confusing, like seeing that, that's okay. You don't have to do it like this. This is just kind of a counting shortcut. If you expand the whole thing out, that also works, and that will always work. This is just a counting shortcut for when you see these polyatomic ions. You can think of them as a group, and that just makes counting a little bit faster. All right, here is our last one. And then here we have, we'll split it up and do it the longer way. So this is another one where we have SO3 in parentheses as a polyatomic ion, and then we have it the same thing over here on the left side, and no S's or O's show up in anything else other than this combination here. So we could group it like I did in that previous example. I'll separate it out. So when we do this one, start by counting everything. So on the left side, 1B, 3 F's, 2 Li, 1 S, and 3 O's. On the right side, 2. Sulfur, I have 3 times. Remember, that's like a 1. So 3. Oxygen, 3 times 3 is 9. And then lithium and fluorine, 1 of each over there. So now I'll go through and just element by element. Remember, in ones like this, oxygen is usually the one we want to save for the end. But I'll just go through element by element. So we'll start with boron. So I'll update that, and then that changes my fluorine now to 6. Then if I try to balance fluorine, so fluorine I have 6 over here now, so that means this needs to be a 6. And then that updates lithium, so now I have 6. So to balance lithium, I go back to the left side. I have 2 right now, so this has to be a 3 to get that to balance. And then that also changes these two. So 3 times this sulfur, kind of hidden 1 again, gets us 3 sulfurs. And then 3 times 3 is 9 oxygens. And then it's balanced. So that just automatically took care of sulfur and oxygen. So this one balances 2, 3, 1, 6.